Now, to continue with what we have for today's class, we have so far considered the limits of a function at some real values. We considered values like 2. Okay. The question is, what then happens to functions? Or should I say, how then will functions behave if taken at an infinite number? That is a food for thought. What happens if x approaches a particular number at infinity? Remember what infinity is. Infinity is this sign over here. So what happens if x, remember before we had limits of f of x as x tends to a particular number, a particular real value, a. But our question now is, what happens when we have limits of f of x as x tends to an infinite number? That is what we are going to consider next. So we would have limits at infinity. Limits at infinity, at an infinite number. So for this particular session, let us consider some values. If the values of the independent variable x, remember we've always been working with independent variable x because this is what we are used to. If I change the independent variable to, let's say, m or n, some of you start getting confused. So that's why I maintain my x independent variable. Do you understand? So therefore, if the values of the independent variable x decreases, take note, if it decreases without bounds, without any control, through the negative values, or also increases without bound through the positive value, then we say that that function of x, seen as f of x, has limits at infinity, and it is written as the limit of the function f of x as x approaches infinity is equal to L. Is equal to L. So for instance, if we consider this function below, we want to check how this function f of x, for instance, if f of x equals 1 over 2x. If f of x equals 1 over 2x, and we wish to check the behavior of this particular function as x tends to or approaches positive and negative infinity. So what I'm trying to say is we have the limits of the function 1 over 2x as x tends to infinity. That is what we're looking for. Okay? Then equal to, it must be equal to something. It must be equal to a value. But that value we don't know yet. I'll show you in a short while. Excuse me. It must be equal to a particular value. Now, since we said that we're going to use negative to show the limit approaching from the left and positive to show the limit that approaches from the right. So we can say that this is plus and the limit of the function 1 over 2x as x approaches infinity from the left. So this is seen as the right hand limit, while this is seen as the left hand limit. So we want to check, like we did in the first case. Let us draw a table to illustrate it. We have x and we have y. And y is the function f of x equals 1 over 2x. So this is it. Let us consider some arbitrary values. Remember, infinity. So if you consider 10 raised to power minus 10 raised to power 3, start from 10 raised to power 4, so minus 10 raised to power 4, we have minus 10 raised to power 5, minus 5, we have 10 raised to power 4 minus 10 raised to power 5, we have 10 raised to power 5, 10 raised to power 4, and so on and so forth. For this lack of space, remember we have some values approaching from this end, and we also have some values approaching from the other end. So what then is the value of our f of x? Simply, what we are asked to do is to substitute the value of x into this particular function. So when x is equal to minus 10 raised to power 4, what is the value of f of x? If you do that, if you punch your calculator, you have that this is minus 0.00005. Okay. Now, if you do for minus 10 raised to power 5, you have minus 0.000005. If you do for 10 raised to power 5, you have 0.000005. Then for 10 raised to power 4, we have 0.00005. So you can confirm that. Now, it will be observed. If you observe, you will see that the value of f of x, which is 1 over 2x, approaches a definite value. And what is that definite value? 0. Be it from the left or from the right. So we can conclude that the limits of any value whatsoever, insofar as the value approaches infinity from either the left or the right. If you have the function of the limits of a function of x as x approaches infinity from the left, will be equal to the same if f of x approaches from the right, and this will definitely be equal to a particular value, a definite value, which is 0. So wherever you go, be it, in fact, anywhere, it stands sure that the limit of any function whatsoever as it tends to infinity, either from the left or from the right, is equal to 0. Most times, the examiner might want to confuse you and give you a particular question, probably question 1. The limit of a particular function, let's say 3x squared, square root of 3x squared minus 5, something like this. Limit of f of x, let's say the f of x is square root of 3x minus 5 as x tends to infinity plus. You will now give option A minus 20, option B 25, don't just bother yourself to solve. This is a concluded answer. And if anybody asks you who told you this, tell them it is Akada. Is that okay? I can stand to it anytime. So the limit of any function whatsoever, insofar as it approaches infinity from the left to the right, is equal to no other number but 0. You have to take note of these very, very well. So before we end the class, I'm sure we still have enough time, but I will not go any further, so I'll be able to digest what we already have. Let us take an example. The first example is find the limits of the following. Find the limits of the following. And the following functions are f of x, as the first one, f of x is equal to square root of 3x minus 7, and f of x equal to 3 over the square root of x minus 4. As in this first case, as x tends to positive infinity, and in this second case, as x tends to negative infinity. Some textbooks will write it as this, while some will write it as this. Don't get confused. They are still the same thing. Some might write this as this or as this. They are still talking about the same thing. Alright, looking at this problem, I'm sure most of you will start panicking. What is this again? What is this? What is this? Don't worry. You don't even have to solve. In fact, probably in our next class or next 2 classes, I will show you how limit is very, very easy. Most times, you don't have to pick your pen to do anything. Did you get it? It's just for you to know the methods to go around any question. And I'm going to show you all those methods in due time. Just make sure you come to class and sit with us. Okay? Now, the function square root of 3x minus 7 as x approaches positive infinity. What we'll just have to do is to find lim square root of 3x minus 7 as x approaches infinity. And I told you that don't just bother yourself to solve. Once you check this place and it approaches infinity, be it from the left or to the right, the answer is always 0. Therefore, the second answer will be nothing else than the limit of 3 over the square root of x minus 4 as x approaches a negative infinity will also give me a value equal to 0, because it is just seen as a standard in mathematics. With this, we have come to the end of today's class. In our next class, we'll talk about the properties of limits. And once we are done with that, we'll solve some examples, then end the class on that note too. Then if we have an opportunity in our next class, we'll start in the subsequent class, we'll start with the concept of continuity. And I'm sure you enjoyed the class today. If you have questions for me, you know what to do. Just go to the platform and drop your questions there. I'm going to attend to them in due time. So have a nice evening and bye for now.